In this video, we're going to talk about simplifying exponential expressions involving rational exponents. So, I've written the exponent rules that we have discussed earlier in this course. So stop the video now to look these over. Alright, let's take a look at a couple of examples then. So here I'm multiplying exponents with the same base. So when I multiply exponents with the same base, I add the powers. So the base stays the same at 7. 10 over 6 plus 2 over 6 is 12 over 6. Well, that simplifies to 2, and 7 squared is equal to 49. Okay, let's take a look at the next example. We are dividing exponents with the same base, so you subtract the powers. Well, 1/5 minus 11/5 is negative 10/5. Negative 10/5 simplifies to negative 2. Simplify the negative exponent, and 5 squared is equal to 25. Okay, for the next example, we're taking an exponent power to another power. When you do this, you multiply the exponent powers. So I'm going to do the work on the side now. So 9/4 times 8/3, I can divide out a factor of 3 and a factor of 4. So that leaves me with x to the 6th. So I will do the 3/2 times 8/3. 3's divide out. I can divide out a factor of 2, and that ends up being y to the 4th. Okay, let's take a look at two other examples with this. So here I'm taking an exponent power to another power, and I am multiplying. Well, order of operations says I need to take care of the exponent first. So power to a power. This 3 is to the first, so 1 times 4, that is 4. 3/2 times 4 over 1. I can divide out a 2. That gives me x to the 6th. 1/4 times 4, that is 1, so that's just y. 2/3 times 12. I can divide out a factor of 3. That leaves me with x to the 8th. 3/4 times 12. I can divide out a factor of 4. That gives me y to the 9th. Well, 3 to the 4th, that's 81. I am now multiplying exponents with the same base, so I add the powers. So that's x to the 14th and y to the 10th. Okay, for the next example, what I will do first is I'm going to simplify what is inside the parentheses first. Well, the 9 will stay the same. Remember, when you divide exponents with the same base, you subtract. So that's x to the first. So that's 1 minus 5/4. That's the same thing as 4/4 minus 5/4. That's negative 1/4. So we have x to the negative 1/4. 2/3 minus a negative 2/3. That's the same thing as y plus 2/3. So that's y to the 4/3. And I'm taking all of this to the 1/2 power. Well, that ends up being 9 to the 1/2. Exponent power to another power, you multiply. That's negative 1/8. And this is 4/6, which reduces to 2/3. 9 to the 1/2 is the same thing as the square root of 9, that is 3. Because x has a negative exponent power of 1/8, that goes to the denominator, and y to the 2/3 will remain in the numerator. Okay, for the other part of this video, I'm going to convert radical expressions to rational exponents and then simplify. So let's take a look at the first example. Well, I can rewrite this as a rational exponent, 36, taken to the 5, divided by 10 power. 5 over 10 simplifies to 1/2. 36 to the 1/2 is the same thing as the square root of 36, and the square root of 36 is 6. Okay, so now I'm multiplying. First thing I'm going to do is convert these to rational exponents. Well, the first one is x to the 3/5. This one is x to the 1/3. Remember, when I multiply exponents with the same base, I add the exponent powers. So I'll do that on the side now. And when I do that, I get 14 over 15. So my answer here is x to the 14 divided by 15th power. If they ask you to write that as a radical, that would be the 15th root of x to the 14th. Okay, let's take a look at the next example. So here I have the square root of the 5th root of x. Well, I can rewrite that using rational exponents. I'm starting with the inside, that is x to the 1/5. And the outside, that's a square root, so I'm taking that to the 1/2 power. When I take an exponent power to another power, I multiply. So that's x to the 1/10th power. And that's the same thing as the 10th root of x. Okay, one other example. Again, the first thing I will do is I will write these as rational exponents. The numerator is x to the 2/3. The denominator is x to the 1/4. When you are dividing exponents with the same base, you subtract powers. So when I do that, I get this. So here I get x taken to the 5/12th power. If I want to write that as a radical, that would be the 12th root of x to the 5th.